Hi guys, in this video we're going to be covering Newton's laws, an example. So the example I chose is based on question 4 of the Free State trial exam in 2014. Just a bit of background into Newton's laws types of questions. Most of the time you'll be tested on Newton's universal law of gravitation or Newton's second law. Newton's first law and Newton's third law are also very important. They're always tested in multiple choice or as smaller sub-questions. One of the hints you can notice when a multiple choice question or if asked in a small question whether it's Newton's first, second, or third law. In Newton's first law, they'll often say that there's no external forces, the object's moving in a vacuum at constant velocity, there are no other forces applied. There's no external forces. So that tells us Newton's first law, and then, because you remember from the definition of it. So what we're going to do now is we're going to go through this example from the past paper. So you have a truck that is basically towing a car and is connected by a metal rod. The car's mass is 2,100 kgs. The car's mass 700 kgs. The coefficient of static friction is 0.35. Coefficient of kinetic friction is 0.2, and this applies to both the truck and the car. So the first thing they ask in the question paper is to define Newton's second law. So Newton's second law is described as when a resultant force acts on an object, the object accelerates in the direction of the resultant force. That's the first part. The second part of the definition is the acceleration produced is directly proportional to the resultant force and inversely proportional to the mass of the object. So that you can just remember from the formula F is equal to ma. That's the first part. In the second part, we can just say that you make sure you write it in words, but just for the sake of this video, is like that. Sorry, we can just say F over m is equal to a, and just make some room here, and we can say that the force is directly proportional to the acceleration, and the acceleration is directly proportional to the force, and the acceleration is inversely proportional to the mass. So that's just Newton's second law definition. So the next question asks you to calculate the magnitude of the minimum force required to get the car to start moving. So which object are we looking at? We're looking at the car, and the car needs to start moving. The car needs to start moving. That means the car was stationary. So if you remember from the formula sheet or from previous year's work, that the coefficient of static friction, the maximum force required, the maximum force the minimum force required to get an object to move is called the maximum static force that can be applied, static frictional force. So anything involved with friction, we know that the frictional force, any frictional force, will be equal to the coefficient of that friction times the normal involved in that friction. So in this case, let me just make this a little bit easier for myself to write and make some room here. So in this case, we want the minimum force required to get the car to start moving. That means the maximum static frictional force, and it's the car. So that means the force required is equal to U static times the normal of the car. So that's equal to U static. The normal of the car is equal to the. So we understand. Let's just draw a diagram to make this a bit easier. Normal will be equal to the weight in this case. The normal is the force applied by a surface on the object, and this will be equal to the weight in most cases, and this is when there's no inclined plane. In that case, when there's an inclined plane, then the normal will be equal to the perpendicular component of the weight. But for now, in this case, it's a car, it's on a flat road, so the normal is the force exerted by the surface on the object, which in this case is equal to the weight of the car. So weight is equal to, so we know that normal is equal to the weight, but in the opposite direction, so there's only magnitudes here, which can be also equal to the mass times gravitational force. So this is the mass of the car times g. Let's look at what the mass of the car is. So we got static friction. We're looking at static friction, so we're going to take that, and the mass of the car of 700. So I'm going to come down here, and we're going to say static friction 0.35 times the mass of the car 700 times force of gravity, which is 9.8, and that is going to give you the frictional force, or force required, of 2401. That gets you 3 marks. You get a mark for writing your formula, your normal force. This can also be written alternatively as F, the force static max. I would have actually written it as frictional force static max is equal to US times the force of the normal. That's an alternative way to write it. But you get a mark for that, or that, it's 1 here. You get a mark for substitution and a mark for the final answer. Alright, let's move on to the next question. Okay, we're given a little bit more information here. The force exerted by the truck is equal to 20,000 newtons, and the truck car system accelerates constantly at 6.08 meters per second. Draw a fully labeled free body diagram for the truck, horizontal forces only. So they want you to draw a fully labeled free body diagram for the truck. So there's the truck here. Okay, so remember, the first thing you do when they ask for a free body diagram is to draw a free body, which is a circle. We also know that the truck applies 20,000 newtons this way. So we've got force applied. What other forces can be acting? Also acting on this system horizontally, sorry. We have your tension force here, obviously. And obviously the other force, since it's not a frictionless surface, will be a friction. Notice that the truck is moving in that direction. So that means friction will be working in the opposite direction to that. So if you come down here, you can write the tension force here, the tension, and your frictional force here. Frictional force. And that's your free body diagram. You can also write a key when you write force for each of these to describe what they are a bit nicely. But that's pretty much it. They only ask for the horizontal forces. If they did ask for the vertical forces or the whole free body diagram, you would have obviously added your normal and your weight. But they didn't ask for it in this question. We just added it down there. So just make sure that your drawing, your free body diagram, actually has arrows, that everything is touching here, and that you have your labels. Those are the most important thing for this type of drawing. Right. Finally, the last thing to do is to ask you to calculate the magnitude of t. So you can either work out the magnitude of t. So you can choose either system, because the car and the truck both have t involved. Personally, let's use in this example. Let's use the truck system. We can actually go through both if you'd like. Actually, I think I will do that. So let's do the truck system first. So for the truck, we know that F net is equal to ma. We were given the mass and the acceleration. But let's break this down first. What is the net force? Net force is the resultant force of the sum of the forces acting on the truck. So you'll have your force applied plus your tension force plus your frictional force is equal to mass acceleration. Also, an important thing that you can do initially is to take a direction as positive. So we can do this, taking left to be positive in this case, because that's the direction of the car. The force applied was given, so it's given as 20. The tension force, let's just add tension, plus, actually we know the frictional force, actually we don't know the frictional force. The frictional force can be calculated by saying the frictional force is calculated by taking the mass times the normal times the coefficient times gravitational force. So it's basically the coefficient of kinetic friction, because the truck is moving, times the mass of the truck. So let's just add that in. We also know that friction is working in the opposite direction, so we can actually make that negative. We can say that it's equal to UK into mass of the truck times G is equal to MA, 20,000 plus tension minus coefficient of kinetic friction, so it was 0.2. The mass of the truck was given as 2,100. So go back here. 100. And your gravitational force 9.8. Again, we can take the mass of the truck here as 2,100 times acceleration, which was 6.08, if I remember correctly. Right. So let's go. We can just plug everything into our calculator. Let's just plug it in to make it a bit easier to write. 0.2 times 2,100 times 7.8. That's just going to give you 20,000 plus tension minus 2.116 is equal to 2,100 times 12768. There's a 0 there. Okay. So we just take all the values aside, leaving tension alone, because that's what we need to calculate. So we can take this answer minus 1446 minus 20 gives you an answer of minus 11348. Right. So what this means is that tension is 11,348 newtons in the direction opposite to the direction that we chose as positive. So in this case, we chose positive as left. So tension, final answer will be 11,348 newtons, and that will be to the right. But in this question, they actually ask you for the magnitude only. So you can therefore say, if you'd like, actually what you're actually supposed to do, that was just in case they didn't. So that you would say that tension is equal to 11,348 newtons. This is your magnitude. Remember that forces are vector quantities. You should always have magnitude and direction, but in this case they ask you only for the magnitude, so that was all that was required. That's pretty much how you do a Newton's law question. Often this will be the case where you'll be asked to state one of the laws, and then given the different parameters, you have to just calculate for either tension or coefficient of friction. Just need to know all your formulas, make sure you have them all there in front of you. The formula sheet will be given. So draw free body diagrams, whatever makes it easier for you, and that's pretty much how you do that. So yeah, next video we'll probably move on to momentum and impulse, but if necessary I'll do another example on Newton's laws. Okay, thanks.